So good evening. Today the marks of the fourth day of our online digital series. On this occasion, we are privileged to engage in a discussion one of the most important and fascinating emerging technologies, that is the drone technology. The session will be delivered by Mr. Bebeto Ally, who has been engaged in long-term research and scholarly work in this field. So I extend a warm welcome to Mr. Bebeto Ally and thank him for joining us today. Mr. Ali is a founder, chairman and managing director of the Aerotus Aircraft Research and Development Private Limited, a deep tech aerospace company incubated at IIT Kharagpur. He also a founder of the IIT Kharagpur Aerotus Drone Academy, DGCA RPTO. He also served as the governing body member of the STEP IIT Kharagpur and is actively involved in promoting the startup ecosystem in India, also a member of the SHM IT subcommittee East. He has an experience of more than a decade in aerospace and UAV. Before we proceed, I would like to repeat the two important points or instruction that share at the beginning of each session. Participants are kindly requested to keep their microphone and camera switch off during this session, to ensure a smooth and uninterrupted session. A dedicated question answer session will be at the end of this session, and you can directly interact with the speaker. If you have a question, you can ask the question. You raise your hand and I will select accordingly. Okay. So with this, we now move to the main session. I invite Mr. Ali to begin his lecture. Mr. Ali, please. You are not audible. Please unmute your microphone.
Oh, yeah. So good evening, everyone. So as you're aware that we are going to conduct a workshop on drones and aerospace today. So drones and aerospace is a emerging technology, not just for India but globally. As you have seen recently, the drone market in India and globally, it has grown up to $40 billion, and it's going to grow up to another 40 billion by the next 5 years. So our main objective in India is to promote Atmanirbhar Bharat to support the goal which India has to make it a Vikshit Bharat, which is developed Bharat by 2047. So we are promoting Make in India drones, trying to make it 100% indigenously developed, so that we don't have to depend on, not just in drones but in other technology. We can be indigenous. We have indigenous technology which will be working in India itself, rather than depending on foreign goods. So drones are playing a important role in civilian as well as the defense part in India. As you have seen recently in Operation Sindoor, how drones helped us win the war against our enemy Pakistan. So similarly, the drones have also helped us in saving lives of soldiers. As you know that drones are unmanned aerial vehicles, which stands for UAV, unmanned aerial vehicles, or UAS, unmanned aerial systems. So these systems enable you to remotely, access the areas which are inaccessible. And instead of a person being on board, in case of a fighter aircraft or an airplane, you are sending the aircraft remotely, which stands for UAS, and you can, do your activities and come out of it without harming any humans there. So this is the key objective of UAS and UAVs, which stands as well as drones. As I think all of you are aware, how we have seen it happening all around, especially during the Operation Sindoor. So today I'll be discussing, drones or focus on Atmanirbhar Bharat. I'll also go a bit about the drone, and how it evolved from the aircraft and how the autopilot systems were developed, how an aircraft was developed over the last century, and the structural parts, the technological aspects, the autopilot, development of the first autopilot modules, and other technological aspects over the years, and how it was related to drones. And I'll come through air modeling part as well, how the air modeling and designing and conceptualizing the real aircrafts, which has been happening for the last 3 to 4 decades, and which has helped us to bring up new designs in the aircraft industry, be it in the subsonic or be in the supersonic. And in the coming future, we are also working on the hypersonic type of aircrafts. So apart from that, the drone applications, the drone industry, the job opportunities, and how you can be a part of this drone industry. As I can understand, there are students, many students of engineering, especially from BTech. So there's a huge opportunity for you, to be a part of this industry. We'll also discuss drone mobility and unmanned aerial systems, for the manned part of the like the air taxis and the air ambulances, how it can be useful in India as well. And after that, as Mr. Shandal said, that we'll have the question answer session. So I'll straight away begin with the presentation. So I'll just take a confirmation. Is my screen visible?
Yes, yes, it is visible.
Okay. So So I'll be beginning with the presentation. As I mentioned earlier, that our focus will be Atmanirbhar Bharat, to promote indigenous, technology, and to be less dependent on, foreign goods for any of the technological development. So according to the Atmanirbhar initiative, we have to be 60 to 70% make in India, and the remaining 40% components that cannot be made in India at this time. So that is all as part of the objective of the Atmanirbhar Bharat initiative. So I'll straight away come, as you know, there are three categories of drones. So one is the surface drone, one is the underwater drone, and one is an aerial drone, or which we call an unmanned aerial vehicle (UAV). So it's basically an aircraft without a human pilot, an aircraft which does not need a human pilot to fly, which can be remotely operated, or it can be autonomously operated from anywhere across the world. So this is a drone. So today we'll be discussing what is a drone. So before we begin, we need to understand how many types of drones are there. So uh, basically, there are two basic types of drone. One is the multi-rotor category, which has four propellers, which is commonly observed everywhere, be it with the camera or something. And another one is the fixed wing, which looks like an aircraft, and it is capable of covering, huge amount of distances at a very small time. And these drones are basically, for long range operations, and whereas multi-rotors usually have a very limited range and very limited speed. So these are the two categories, and apart from that, there are multiple classifications in these two categories, which I'll come up on next. So as I mentioned earlier, that the drone market is going to reach approximately $40 billion by 2026, and it is going to be approximately the double by 2030, which is $80 billion. Now, drones are, being used in civil and military applications. In the civil, we are using it for policing, we are using it for civil defense, we are using it for agriculture extensively, especially the few of the schemes launched by the Honorable Prime Minister, which is the Namo Drone DD scheme, where the farmers, especially the self-help group farmers, they are being taught how to, fly a drone, provided a drone with subsidy, so that they can use agriculture drones instead of manually going into the fields for spraying fertilizers and insecticides, which is very harmful for their health as well. This is also giving them an employment opportunity, and at a very which is helping them become an entrepreneur, and earn a livelihood from the drone by providing agriculture spray services. And they are also being provided with the DGCA certification, which stands for the RPC, Remote Pilot Certification. It's basically a legal certification or a license which is provided by DGCA to legally fly a drone anywhere across India in the civil airspace. So drone technology, it's mattering a lot across India, as it's having a diversified sector. It's in multiple sectors, and drone has made work for every field, be it from land mapping to surveillance to agriculture to for construction work or security. It's everywhere. It's helping us to make our lives more easier. So India's EAV revolution, which I mentioned that it will be with Atmanirbhar Bharat in drone technology. It means that we have to focus on indigenous development rather than for getting our goods from outside, which I mentioned earlier, be it in drone technology or any other domain. So as I mentioned that I will be speaking about aero modeling and how it evolved the drone technology over the years. So, in aero modeling was basically started in the early, say 50 to 60 years ago, in an era where we didn't have computer simulations to design an aircraft. So as you have heard about the world's first aircraft, the first commercial aircraft, which was the DC-3, the Dolgus aircraft 3, which was a piston engine aircraft, and it had a commercial operations from 1932 to almost to the late 60s. So these kind of aircrafts were developed using the aero modeling aspects. The first, a small scale down model was designed. It was tested on various scenarios, because in those days you never had a wind tunnel. I'll come later that what a wind tunnel is. So there was various things that had to be checked. So these were done using this small scale down models of this large aircraft. So in fact, Boeing, Airbus, Lockheed, all these top brands, which used to be in those days, be it in fact, the Concorde itself, a scale down model was made to check the supersonic aspects. Now, in those days, the aero modeling, because we didn't have a proper technology to fly it remotely, unmanned aerial, which we call it today UAVs, we fly it using 2.4 gigahertz radio, but those days it was not possible. So they used to fly it using wired controllers. So these models in those days used to be connected to a wire, and they could only circle the ground to check whether the aerodynamical aspects are perfectly working or not, to check the drag, to check the drag coefficient, to check the angle of attacks of the wings, whether it's functioning properly. So once all the tests were done, so everything was all manual, because it was an era when we never had computer simulation. So that's where the aero modeling came up. The aero modeling concept was born, and over the years, when our technology evolved from the early 70s to 80s, we had the first bandwidth, the 2.4 gigahertz, which helped us to fly these drones remotely, which is now evolved as a drone technology. So these drones are basically, I think most of your engineering students, you might be aware of these events that is organized in IIT, called the Boeing IIT National Aero Modeling Competitions, which is organized across all IIT, and one zonal competition is one national competition is held in either in IIT Delhi or IIT Madras. So this competition is backed by Boeing, and Boeing has been doing it for almost for 2 decades now, to promote indigenous development in India. So I'll straight away get to the next part. So this is the aero modeling, one of the pictures from the aero modeling competition that is held in IIT Bombay. So as you can see, there are several model aircrafts. So these model aircrafts are not just for any competition. If you think, it's not for any competition, but it is for seeing whether which one of the designs can be taken up for the next proper aircraft design. Boeing comes up with new aircrafts every year almost. They take up new prototypes, new concepts. So all these ideas, the bright minds are taken up from all these thousands of designs that come across the country participating in these competitions. which give them the the idea to that what kind of an aircraft can be made in the future. So, in the aero modeling, as I mentioned, that you needed very basic components. So one of the first component is the TXRX module, which is a radio, which consists of one, one radio and one receiver. The receiver is basically mounted on the on the aircraft or the model aircraft. You have one battery, you have one BLDC motor, and one electronic speed controller, and that's all is a part of the electronics in a aircraft and a model aircraft in aero modeling. It's a very simple technology. How it flies, you just need to mount these three things: BLDC, ESC. ESC stands for electronic speed controller, and BLDC means a brushless DC motor. So these are the three basic components which were being used over the last 3 to 4 decades to fly such aero model, do such aero modeling, designs and check the aspects of the aircraft in a scaled down manner, and which later on evolved to be a competitive term, as I mentioned about the Boeing IIT competitions and also the SE International, which is held in the US. So there are many such events that happening over the years. So this is the basic component. Now, how when we had this technology over the years, why didn't we have the UAV technology developed? Today how popular it is. Why didn't we have it? Way back, say 15 or 20 years back. So in the next slide, this is an add-on. This is what is added in today's be it a quadcopter or be it a airplane structure in the for an unmanned aerial vehicle. This is the flight controller, and one of the most commonly used flight controller. This is basically called the APM, autopilot module. This is a complete combination of a, I must say that it's a scaled down version of a real aircraft's autopilot system. It's the same system, is the same aspect how it works. It has a inbuilt gyroscope which stabilizes the aircraft and the multi-rotor drone also. So it is something that has revolutionized and made flying drones and aircrafts more easier, which was not possible because all these years without an APM, the flying an aircraft, flying in a or an RC multi-rotor was all manual. It was all about balance. It was all about precision. It was all about practice. So today the things have become much easier because of the development of the autopilot module, which is here. It is one of the examples. This is one of a flight controller which is being used and which has been there for for almost a decade now. So since then, when the first APM module was developed, it has revolutionized the drone industry, and we found out that how much how many things can be done from beginning from very basic the photography, which is commonly done, to agriculture, to winning a war. So there are many things that has come up after the development of the APM module. So over the basic component, as I mentioned, that one TXRX, one BLDC, one ESC, and a battery. This is just one APM module, the complete set of the APM model, which has revolutionized the entire industry. So as I mentioned, that wind tunnel test, it is very important for when you are designing an aircraft or a multi-rotor, be it an unmanned aerial system today, because you need to understand the aerospace aspect, whether your wing is generating sufficient amount of lift, which is very much essential for your flying, whether your structure is stable or not, is there any drag. So this wind tunnel test is very important to know about your aircraft's efficiency. And as I mentioned earlier, that in the early days, maybe 6 to 7 decades ago, we never had such technology. So those days aero modeling was being done, but today a scaled down model, or even sometimes for the unmanned aerial system, proper scale model, not a scale model, the exact model is placed inside the wind tunnel so that we can do such testings. So this is a wind tunnel. As you can see, one aircraft is placed there. So, and the speed, the in a wind tunnel, the air blows at a very high speed, and basically you're given, sometimes it's smoke depending on which kind of a wind tunnel it is, so that you can understand the flow of air through the wings and how it's flowing across the surfaces of the aircraft. So this is an example of a manual flight. As I mentioned that before, the APM, the autopilot modules were used extensively, or they were, innovated in a proper way. We had to do manual flying. So I'll just show you a video how manual flying looks like, which is, completely on balance. This is not. There is nowhere that software is flying this drone. It is all manual flying. So I'll straight away play this video so you'll understand how it works. So as I mentioned earlier, this was a manual flying, where you don't have an APM, but it's all about practice and precision. If you don't have a practice, you're unable to fly this aircraft. So once the APM modules were innovated, flying such aircrafts became easy. But if somebody, or maybe, earlier days students used to make their planes maybe a decade ago, this video is from 15 years ago, which was being flown in Kolkata Maidan. So this aircraft is on all manual flying. But in those days, when engineering students used to make such aircraft, so they used to face a lot of trouble while flying it because they lacked the flying skill. But in today, after the innovation of the APM, which is auto stable, it does not require you to maintain stability. All you have to figure out that where you want to fly and when you want to fly. So this is where the advantage of an APM lies, and that has revolutionized the industry. As I mentioned, globally it's $40 billion, which could have been done a decade or 15 years ago if it was there. We had the same technology, we just didn't have the autopilot modules. So I'll just say the types of wings that are there for or a fixed wing aircraft. So one is the dihedral wing, one are flat wings. You must have noticed in trainer aircrafts like the Cessna. Then we have the anhydral. So anhydral is basically used in the heavy lift aircraft like the Antonov or the Boeing C-17, which are basically designed for cargo lifting, like the Antonov AN-225, which is now destroyed. It had an anhydral configuration wing so that it can take more load while takeoff and landing as well. So these are the types of wings that are commonly used. And the dihedral wing is basically used in a jetliner like the Boeing, all the Boeing and the Airbus planes mostly. So basically, I'll just discuss about the types of multi-rotor. One is the quad, which is commonly used. It has 4 axes. It is normally used for, you must have seen it for photography or other small things. Then we have the hexacopter, which has 6 axes, which means that it has 6 BLDC motors or 6 propellers, which helps it to fly. And these are mainly into the agricultural sector, like the agricultural drones. You also have it in defense, and also for various other purposes. Then we have the octa or the 8 axis. This is very rarely find, you'll very rarely find this kind of octocopters in a large scale. other than if you see for the air mobility, you have air ambulances and air taxis, which have been configured to octa configuration to generate more thrust. So they basically we here you can see in the quad you have 4 axis, then in the hexa you have 6 axis, then in the octa you have 8 axis. The reason for this is that in a quad basically you are using maybe a less payload, sometimes maybe a camera or maybe some sensors. So you don't need much thrust to take off. So you don't need more power. So that is why 4 axis is sufficient for for that drone to take off and fly properly. But when we come to the agricultural sector, you're using an agricultural drone to spray approximately 10 to 18 liters of maybe it's urea or insecticide or whatever. So it's a payload that's equivalent to almost 20 to 25 kg, apart from the fluid. So you need more thrust that can be given when you add more BLDC motors at having higher velocity and more thrust that is needed. And octocopter, as I mentioned, for the air mobility, it requires more thrust because it is something that is in the unmanned aerial system category, not in the unmanned aerial vehicle category, because it's going to carry humans. So this is one of the multi-rotor which is configured. It is a quadcopter, but this is a heavy lift quadcopter, which is configured in the coaxial configuration or counter rotating. So this has basically instead of one BLDC in each axis, it has two BLDC motors in each axis, which has counter rotating capability. So basically, this is an octocopter in a quad configuration. So I'll straight away play a video of this heavy lift multi-rotor.
Mr. Ali, please unmute your microphone. Hello.
Hello.
Yes, yes, yes. Now you are audible. Actually, Please, yeah,
Yeah. Okay. So was the video visible?
yeah, it is visible, but there is
Okay.
no sound.
No, there is no sound in this video actually.
Okay, okay.
Yeah.
Sometimes you actually mute your microphone, so therefore,
No,
number
no, no.
participant actually
There is no. So
requested. Okay.
as you have seen in this video that this is a coaxial, which is a heavy lift drone designed for payload dropping. Okay. So this drone is capable of lifting weights up to say 25 to 30 kg. Right now, it is going to drop a payload of 5 kg. Okay. So this is a coaxial configured quad. As I mentioned earlier, that hexacopters are designed for bigger drones, but this drone is designed in such a way it's the quad being in a small configuration but generating more thrust than a hexacopter of its category. So there are various such categories of drones that work, and it helps you to do your functionality according to your requirement, your flying time. So basically, when you design a drone, first you need to think about the structural aspect, the kind of payload, the volume of the payload, and the flying time. That's very important, that you need to do a calculation of your battery, that whether the flying time you're planning for with that amount of payload, the structural load, your drone is going to withstand that kind of flying time or not, and what kind of a battery are you going to need, and what will be your circuit diagram. That's very important when you are developing a drone. So students who are interested, I can understand that's why they're attending this workshop today. So it is a very important thing to know your requirements, know your payload before you start developing a drone. So I'll straight away come to the next slide. So the main electrical components of an UAV, as I already showed you the pictures of the basic components and the autopilot module. So I'll straight away state that each there is also one more thing that I did mention in the previous one. I mentioned about the BLDC motors, but there is also one more thing, that's an IC engine. That's an internal combustion engine, which is either fueled by either sometimes be by aviation fuel or methanol. So these are the two forms of fuels which it runs on, but it is very rarely used because, as you know, we are trying to promote a greener technology over the time. But in some cases, in some operations, especially in defense, we need IC engines to gain that kind of speed, that kind of for that kind of a mission to reach sometimes for the supersonic missions, or as the hypersonic missions, the prototypes are in the development. So for those things, we need an engine, not an IC engine, but obviously a more powerful engine or, for those operations. But an IC engine UAV is also there, which is being used for in the defense for various uses. Now ESC is something. It's an electronic speed controller. As I mentioned earlier, it controls the speed of the motor from the it gets the signals from the RX module. Then you have the autopilot system, the APM module, which has the flight, which is an integrated version, which has the internal gyro and everything, which maintains your flight path and with a stable flight. So that's a very important thing. Then you have the GPS, which helps you to find your location. It's a part of the APM module. Then the propeller and the structural frame. This is the main components of an UAV. Structure frame, you have to design it yourself, make it either out of carbon fiber or aluminum or sometimes titanium. So these are the three commonly used materials that are used for making an UAV. But sometimes, some other materials, that is for the R&D to save cost. They also use such materials, but commonly the most preferred material is the aluminum. Sorry, the carbon fiber. So as I mentioned about the materials, it's aluminum, carbon fiber. Duralumin is used for for the landing gear section, which helps you to maintain your when you are landing with a huge amount of payload. So if suppose if it's a multi-rotor and you don't, it has to withstand the structural load. So duralumin is very much useful in that case. Then we have also titanium, which is a bit on the higher side, but it's a very good material to construct a drone. But carbon fiber is the most commonly used material in today's drone industry. So important points before designing an UAV, as I mentioned it earlier during while the video is being played. So the payload calculations are very important. You need to understand. You need to analyze your payload, the volume of the payload before you begin designing the drone. Then you start beginning with you begin designing your drone, be it a multi-rotor or a fixed wing, and you have to know that if it's what kind of category it is falling in. Whether you need to try the distance also matters. So based on that also you need to think about the type of the multi-rotor you want to make or a fixed wing, whichever is applicable for that kind of a mission. The range is very important as well. So the applications mostly that's being used for multi-rotor is the aerial surveillance photography. So as you know that the aerial surveillance has become very popular in various industries, from used by the police, the border security force, the coast guards, the various entities like the ports, the in fact today the railways are using drones for the surveillance of their property, and the survey of the railway tracks, the bridges. So it's a very useful tool. Drones have become a very useful tool you know over the past decade, that has made things very easier, which was sometimes maybe a few years ago it was very difficult to get those for example, I'll just give you a very easy example of that: the Howrah Bridge, which is in Kolkata, and it is one of the you know oldest bridge in the country, and it is a cantilever bridge. And this bridge needed inspection for the structural audit. So people had to go up and by the traditional methods, but now using the drones it has become much easier to do the structural analysis. Nobody has to go up all the way to check whether there are any cracks or any rusting all across. So that's how the aerial surveillance and photography has helped us to do our work much easily. Then comes the mapping. As you know that land mapping is very popular across India, and the Survey of India has already begun their operation in mapping the entire all the lands all across the country, so that they have a proper map of the lands they have, where and kind of, which will make their work more easy. So mapping is also very helpful, that has been helping us over the decade. Then we have structural inspection, as I mentioned. Then agriculture. Today we can spray a huge amount of land, agricultural land, with fertilizers and with insecticides in a very less time. So that is a very useful tool, and this is also creating entrepreneurship opportunities for the farmers, especially the self-help group, through the schemes uh, launched by the government of India, which is the Namo Drone Didi scheme, which is very, very, a nice scheme, which is helping to promote the rural agriculture by giving them entrepreneurship opportunities. They have been given subsidies so that they can buy such drones. So this is also helping them, from protecting them from the health hazards that they face when they are spraying this manually. Especially for the lungs, and which they face commonly because of spraying it manually. So then delivery, the logistics part is very important, especially for defense or in flood. Say in Assam, you have, flood and landslides. So in this cases, what's happening is that whenever the roads are getting disconnected, and, sending emergency supplies becomes difficult. And in most terrain, that helicopters like even the biggest helicopter taking it there, it's quite difficult because of the no landing opportunity. So you basically have to drop the payload or the relief material from a very higher altitude. So that becomes very difficult to reach inaccessible areas. So drone delivery has become very popular across such regions, and also for war hit areas like the Ladakh, and this places the defense, the army is using the delivery drones for their supplies, for their initial food supplies, as well as ammunition supplies. So drones have evolved the you know usability of the urban mobility, as I was telling. Instead of sending a truck full of supplies, which takes time, today Indian Army is using drones to send such supplies. Then disaster management is also, as I mentioned, for during a flood and all. So disaster management is and a key important thing about the disaster management is the firefighting. Firefighting, in high-rise buildings, especially in high-rise buildings, when there is a fire, it becomes very difficult to identify the source of the fire from ground level. So initially, to know that where you want to spray the water, so you need to know the source of the fire, which is high above the ground at a very high altitude. So drones act as a bird eye view, and they let them understand that where the source of fire and where they have to exactly spray the water so that they can contain the fire quickly. So this is the flight controller and the main controller of the aircraft, which I mentioned earlier, that it maintains the stability of the UAV. It has a gyroscope. That's how flying a drone is very easy compared to flying a drone maybe a decade ago, before there was an APM. So it would be very difficult. It was all about balance, and today it becomes very easy when you have an flight controller and autopilot module. Now, the effects of wind is very important, to understand this, because when we are flying an aircraft, you have to face, be it a drone, be it an aircraft, that the wind is, it changes the directions. You are going to face updrafts and downdrafts of wind. You are going to face wind gusts. You're going to fly against the wind, which is going to create a lot of turbulence. So wind plays a key factor when you're flying a drone or an aircraft. Now imagine you're flying a drone next to a pole or next to a building, and the wind is coming from the opposite direction. So when the wind comes in contact at the edges of the building, it creates vortexes. Now these vortexes create turbulence when you're flying the drone close to a building. So our APM today are configured in such a way so that we can withstand, we can fly stable in this kind of scenario, but maintaining stability in such at such vortexes, and especially when the updrafts or downdraft, which is a downdraft is a nightmare of any pilot, be it in the aircraft or drone, that if it happens at a lower altitude, you get very less chances to recover from it. So a downdraft is much more deadlier than an updraft. Updraft sends your aircraft up, but downdraft, if you're at a lower altitude, you don't stand a chance to recover. So that's what happened, in 2009, when an aircraft was landing in Schiphol Airport in Amsterdam. So just before landing, they faced this downdraft. So and instead of landing in the runway, they crash landed in the green in the agricultural land, which was just ahead the runway, and it somehow everybody escaped alive. But that happened, that crash happened due to the sudden downdraft of air. So as I mentioned, the downdraft is a nightmare of every pilot, but our so uh, yeah. So so we have to be very careful, and our APM modules are today, it's so stable that we don't even have to worry about such things. But we have to, you need a skill piloting to control and get out of these scenarios safely. So this is the main controls when you fly an unmanned aerial vehicle. One is yaw, one is roll, one is pitch, and one is throttle. So this is a 4-channel TX-RX module, which I showed you a picture when I began this presentation. So basically, the yaw is your in an aircraft, it's a rudder, and it helps to turn the nose right or left. So in case of a drone, it acts the same way. It helps you to turn the turn the front part of an aircraft or the drone right or left. Then is the roll. In case of an aircraft, the roll, the ailerons get activated, and you can turn right, you can move the wings right or left. Then you have the pitch, which helps you to maintain the angle of attack, either you want to go up or you want to descend. So this is where the three controls help, and throttle is controlling your aircraft thrust, which is very, very important while you are doing these maneuvers. Now, there's a difference between the multi-rotor and fixed wing. As I mentioned earlier, that training usually is usually needed to fly one. You need training to fly a fixed wing, but in a multi-rotor, it's easy to control and maneuver because both have APM. But fixed wing requires more training because of its speed, and you can't land it anywhere. You need to learn how to land it and take it off properly and safely. Then you have to know about the ability to hover, and in fixed wing you can't, you have to maintain a fixed position. You are unable to maintain a fixed position, so you have to land it. As I mentioned earlier, that you need to select a proper landing strip so that you can land it safely. So these are the some of the key differences between a multi-rotor and a fixed wing. But there is also one more category which is combined of the both: a fixed wing with the capability of landing and taking off at the from the same location. So that's basically VTOL, vertical takeoff landing fixed wing. So we call it VTOL. So it is a combination of multi-rotor and fixed wing. It can do the both together. So flying a drone in India or flying an unmanned aerial vehicle in India, you need a DGCA certification and license, which is the remote pilot certification from DGCA, so that you can legally fly a drone anywhere across India. So now there are basically 3 to 4 categories of the certification. One is micro, which is for drones of very small, up from 250 grams to up to say 2 kg. Then you have the small category from 2 to 25 kg. Then you have the medium category from 25 to 150 kg. Then you have the large category, which stands from 150 above 150 kg. So you can go up to say 500 or say a 1 ton drone, but that's for the large category. But to legally fly any of these drones, especially the medium and the small, which is very popular, you need to have a certification from DGCA through the drone academies, which is almost, we have 100 drone academies across the country, so that you can get your DGCA certification and legally fly a drone across India anywhere in the civil airspace. So I'll straight away, as I mentioned, that the aerospace part, I'll also be discussing about the aerospace part apart from drones, because the aerospace, the aircraft has helped us, to gain the R&D, the knowledge of how an autopilot can function, and it has given us the key ideas about how an unmanned aerial vehicle also can function. As I mentioned, from aero modeling, uh, the evolution from aero modeling to the unmanned aerial system or an unmanned aerial vehicle. So aircrafts was the medium that has given us the key vision that anything unmanned, an unmanned unmanned vehicle can also fly. I'll begin with the types of aircraft straight away. So there are two basic categories of aircraft today, which is subsonic and supersonic. Subsonic is an aircraft that flies below the speed of sound, that's below Mach 1. And supersonic aircraft are the aircraft that fly, some above Mach 1 and sometimes Mach 2. We have the Concorde that used to fly at Mach 2.2. So these are the two types of aircraft. So I'll straight away come with the first slide in this category. So this is supersonic aircraft Concorde. This was in service for 27 years, and it was the world's first and only commercial aircraft that used to fly at Mach 2.2, and the top speed was 2,179 kilometers per hour. That's twice the speed of sound. So this aircraft, was uh, only first of its kind and the only of its kind that was operational for 27 years for commercial flying. Usually, you will find supersonic aircrafts with the Air Force, the defense all across the world, which is used for military uses, for combat or various other purposes. but this was the sole aircraft in of its time which retired in 2003. So which was providing its services last between New York and London, and the travel time, which is today, it's somewhere 8 to 9 hours. In those days, it used to be 3 to 4 hours, depending on the weather conditions. So that was the slowest, the fastest time that you could reach between London and New York, which is now 8 to 9 hours. So this was the first aircraft of its kind, and this was first flown in uh, uh, 1968, and it was in service from 1971. Now, this aircraft had a faced several challenges during its production and during its service. So there was an air crash that happened in 2000 in the year 2000 in Paris Charles de Gaulle Airport. So as soon as it was about to take off, so moments before it took off, another aircraft had dropped a debris from its aircraft, which was lying on the runway. Now, as soon as this aircraft, as you can see, it is in a delta wing configuration. This is not a conventional wing. It is a delta wing configuration. So delta wing configurations, you will normally find it in supersonic fighter jets or as well. So this is a similar configuration, and the main drawback of this wing is it generates lift. Very it requires very high speed to generate lift. You cannot take off at a very lower speed and generate lift from a delta wing aircraft. So the takeoff speed of this Concorde was above 350 kilometers an hour. So which is more than double of a normal jetliner. So when that piece of debris which was on the runway came in contact with the tires of this Concorde, the tires immediately exploded and it impacted the fuel tank. As you know, in aircraft, the fuel tank is the wing. The wing itself is the fuel tank, and it ruptured the fuel tank, which eventually, due to many other reasons, which I'll not discuss in today's workshop, but there were many aspects like the electrical malfunctions that happened at that very moment, which ignited the fuel tank at that very time. And this Concorde's wing had many weak points because of the structural issues, as I mentioned, that the time in the 1960s, when it was first flown, we didn't have proper computer simulation. So every designing aspect were done using either by manually, by making the aero models out of it, and scale down models, as I mentioned. And that's how they designed this aircraft, and it was one of the finest aircrafts. But still, because they lacked the technology in those times, they missed those weak points in the tank, which a small debris of the tire had ruptured and it ignited. And because the pilot didn't have any chance to stop the aircraft, because the runway was also it was very close to the end of the runway, he had to take off. And eventually, after 90 seconds, the aircraft crashed because it couldn't generate lift any further, because two of his engine were on fire, and so eventually no one survived this crash. So that's when, after a few years, this aircraft was shut because people feared traveling in it, although it was one of the safest aircraft of its time. So this is the story of the Concorde, and it's one of the still in today's world, it's one of the finest aircrafts that the global aviation has ever received. So these are some of the problems that were faced with the Concorde as well. Or when you fly, when you see flying a fighter jet at supersonic speeds. So the most common problem is a sonic boom. This really is very much dangerous if it happens over a city. So that's why an aircraft like Concorde, it was a main reason also why it failed, was never allowed to fly over cities. It was only allowed for overseas operation in for supersonic flight. But when it would fly over the cities, it was supposed to fly at subsonic speed. Now I'll discuss that what is a sonic boom. When you are flying above twice the speed of sound, you are crossing the sound barrier, and this basically creates explosion when when you're flying at an altitude of, say, above 30,000, 40,000 feet. Even at lower altitudes, this sonic boom is so loud that it can shatter the glasses, the window glasses of your house. In fact, damage your ears. And it has happened in the past, and that is why, even today, when you see the Indian Air Force aircraft, when they are approaching the city, they don't fly at supersonic speed. They're only allowed to fly supersonic at altitudes above 49,000 to, say, 59,000 feet. That's the highest altitude. But at lower altitude, because it's very harmful when you're flying over a locality, so supersonic boom is extremely dangerous. So this is a subsonic aircraft, a Boeing A380, a an Airbus A380. Boeing 747 is also subsonic. All the jetliners we have in service today are all subsonic aircraft. A subsonic aircraft is an aircraft that flies at below the speed of sound. It has a maximum airspeed of, say, 800 to 1,000, or sometimes 1,100 kilometers an hour. That's way below the sound, speed of sound, or Mach 1. So these aircrafts are commonly used for commercial jet travel, and are considered the safest mode of travel. So these are the two categories of aircraft. One is the subsonic and one is the supersonic. Now, this aircraft, the de Havilland Comet, is a very important aircraft, and which had revolutionized the aircraft industry or the aviation industry in the early 1950s. So basically, as I said, that aero modeling had helped us evolve into the drone technology. So this aircraft was the first of its kind to use a jetliner, use a jet engine in its airframe, so that it can gain speeds up to, say, 700 to 800 kilometers an hour. Because in its time, the aircraft used to have piston engines, like the DC-3, world's first commercial aircraft. So it was the first of its kind aircraft that could fly above 20,000 feet because of a pressurized cabin. Now, this pressurized cabin was needed because when you're flying in an aircraft above 20,000 feet, you need to have a pressurized cabin, because there's a deficiency of oxygen, and the atmospheric pressure also rises. So it becomes very difficult to breathe at that altitude. So in earlier, when the piston engine aircraft used to fly, they used to fly at 20,000 feet at a very slow speed of, say, 300 or max 350 kilometers an hour. But this aircraft in the 1950s used to fly at, say, 700 to 800 kilometers an hour. But this aircraft gave us, a lot of things to learn, because this aircraft had major air crashes over the, 4 to 5 crashes, until they learned that a structural flaw was identified. After manual simulation, those days there were no computer simulations. What we have today, we stand a benefit, as I'm mentioning every time, that these aircrafts were made through, practical engineering, and making a physical simulation device. I'll just show you the device in the next slide. A water tank was made to identify the structural flaws of this design. So in those days, aircraft components were used to be connected using rivets. Now these rivets were done not in a precision way, so it used to cause microscopic cracks in the structure. And as you know, when an aircraft takes off in a pressurized aircraft, especially a aircraft having a pressurized cabin, when it goes above 20,000 feet and it lands after that, it's called one cycle of flight. Now, during this one cycle of flight, when the cabin pressurizes, it exerts external pressure on the fuselage, the main body of the aircraft. So every time it expands, it changes its shape. When it's above 20,000 feet, goes up to 40,000 feet, and again it comes back to its main position up while it's descending below 20,000 feet. So this entire process is called one cycle of flight. For example, a flight from Kolkata to Delhi, one takeoff and landing, is called one cycle of flight. So during this cycle, the over the time, the rivets, as I mentioned, they were having microscopic cracks due to constant exposure of the pressure, these microscopic cracks grew larger over the time, and eventually failing, and getting, exploding midair, killing everyone on board. So I'll just come to the next slide. One such crash also happened in 1950. 52 in Kolkata. Just after takeoff from Kolkata, it crashed, somewhere next to Dankuni, and everybody on board died. So, how they identified this, structural flaw? So, in those days there were no computer simulations, uh, and eventually you have to, work on making a, same kind of environment which is at above 20,000 feet or 30,000 feet. So what they did, they made a water tank to create the same atmospheric pressure and exert the same cycles of flight by filling the tank again and again, draining it out. And after the, 100 or 200 cycles were completed with this process, at a certain point the fuselage failed. So, that's how they identified the microscopic cracks, and this took them, almost, a couple of years to get the results, which we can get it today very easily. We have devices to identify microscopic cracks, but in those days there were no such devices as well. So eventually it came at the cost of the sacrifice of so many lives. And how they knew it? Because, when the bodies were retrieved. So, the when the autopsies were conducted for the bodies, they found that, the everyone's chests were ruptured when they recovered the body. So that gave them the first sign that the aircraft has disintegrated midair due to a structural flaw. And when they did this test, they got the answers. So, but it came at a cost of time, and during this time, all the fleet of the aircraft were grounded. But in fact, today, if you see the aircraft manufacturers like Boeing, Airbus, Lockheed, DC, they all admit that the comet gave them the clues, because at that time Boeing was developing its first jetliner. So they still admit that if comet crash didn't happen, if comets this huge scale test didn't happen, then they would not they couldn't make aviation flying at that altitude much safer what it's today. So I'll just straight away play the crash of the comet in 1953. That happened in Calcutta. It's an archive video from the news bulletin.
Of the comet disaster near Calcutta. Wreckage of the aircraft smashed almost beyond recognition. Statements taken from local eyewitnesses indicated that a particularly violent storm may have been the cause of the crash. At the time of this terrible accident, the aircraft carried 37 passengers and a crew of 6. All lost their lives. The first fatalities of the Comet passenger services, which had previously carried 28,000 passengers safely. There were many tributes.
So as you've seen in the news bulletin, they are mentioning it was a storm, although when it was identified that what was the actual cause, because four such crashes happened globally at that very same month, because at that time the comet was completing almost 1.5 years of its service in the global in the global travel. So at the very same time it was completing the same amount of cycles of flying and all the aircrafts were failing at the same time. At first, it was considered that it was a normal weather fault, because in those days aircrafts were not that designed to fly through normal or basic storms. But when the tests were conducted over the time, when the aircraft was the investigations were conducted, then they learned that it was a structural failure which had happened, and this aircraft had crashed down in Kolkata. So now I come to the very important part of the autopilot system of an aircraft. So earlier in the 1960s, as you see in the Comet, so they never had autopilot system. But soon the autopilot system was developed at a very basic, in a very basic stage. So thereafter, what started happening was, pilots used to fly the planes like today we drive the cars. They used to keep an eye of the approaching aircraft, just like how you drive a car. So it was becoming very difficult because the kind of speed at that which the pilots fly, it's quite higher. And when the moment they they see the aircraft approaching, they don't have time to retrieve from or change their path. So eventually mid-air collisions became very popular, and it kept happening very frequently. So at that time, because the ATCs, the air traffic controllers, they didn't have the primary the secondary radar. They all reliant on the primary radar. They were also unable to guide the planes properly. So in fact, there was an incident in 97 in India called in the Chakri Dadri, just outside Delhi airport. There was a mid-air collision which killed almost 400 people. So it happened only because the Delhi airport at that time didn't have the secondary radar, which is capable of identifying the altitude of the aircrafts approaching. So basically, what happened? One aircraft was taking off, another aircraft was coming for landing. They were supposed to be separated by 1,000 feet, but eventually they landed up at the same altitude and they collided, which resulted in deaths of 400 people. So the before the collisions kept happening, but they didn't have the technology over the time. Although in 97 TCAS was available, but it was not so widely installed in all the aircrafts globally. So TCAS stands for Traffic Collision Avoidance System. So this system basically helps to identify approaching aircrafts if it's in a collision path. So they basically coordinate, an algorithm is developed so that when the both the TCAS, so TCAS has to be in both the aircrafts. Today all aircrafts have TCAS. So if an aircraft approaching, say, our aircraft flying at 1,000 feet, or say, or at 5,000 feet, another aircraft is also approaching the aircraft at 5,000 feet, it will automatically identify at from a safer distance and instruct the pilot who is flying through a mutual coordination between both the TCAS system. So it will either command each one of the pilot to take off, and another pilot to gain altitude, and other pilot to descend, so that they can have a separation, a safe separation, and they can cross the path easily, with safety. So this normally doesn't happen today because the ATCs have this secondary radar from where they keep an eye on every aircraft, flying in its airspace. But it still happens, and because our if you see the kind of aircrafts flying on the radar in India or in other countries, it's a huge amount of thousands of aircrafts flying together. So having a minimum separation of 1,000 feet apart, so, and following each other at a distance of 1,000 feet also. So these incidents keep happening every day, and TCAS has proven to be very much useful tool in today's air traffic industry. Now, why TCAS is important, and why I'm discussing it today for the drones, because the drones are being used widely and extensively in India. So we have almost close to over say 50,000 to 1 lakh or more than that drones, especially in the agriculture sector today operational. So when you're using such kind of drones in the vast number, and you're especially for the logistics part. So you need to know that where is there any other approaching traffic, so that you don't have a mid-air collision. Because as you know, in case of drones, you don't have a ATC to guide you, or the pilot who is flying, even if he has a DGCA certification, he doesn't have an ATC to guide him that which altitude he has to fly, and he can fly safely through that altitude. So TCAS, maybe in a different form in for aircraft, but TCAS in drones, traffic collision avoidance system, is playing a very major role, especially for the drone logistics, where the drones are traveling say 100 to 150 kilometers, or sometimes more than that, to know that its path is cleared and you can take the cargo or the emergency supplies safely through the from one point to point A to point B. So TCAS is a very important technology which has helped make planes and drones fly safer. Now I'll come to the MCAS system. So this is a very important thing. It's the maneuvering characteristic augmentation system. So this has a very important role in both aircraft and drone. So now you must have heard about the Boeing 737 Max incident. So I think two or three Boeing 737 Max crashed because of, which was stated as unknown reason, but basically it was the failure of the maneuvering characteristic augmentation system sensors that give the readings to the system. The sensors had failed and it was giving a faulty reading, and based on which the MCAS reacted and it crashed the aircraft. Now I'll come to what is an MCAS and why was it installed in a Boeing 737 Max. So as you know that Boeing 737 series of aircraft is one of the oldest series of aircraft that's being manufactured by the Boeing. So we had Boeing 737 NGs, we had Boeing 737 dash 8. Then we had recently, which is in launch, is the Max variant, which has a larger engine. So when they mounted the larger engine, so they had to mount the engines quite ahead of the fuselage, which resulted in shifting of the CG point of the aircraft. To compensate that change of CG, once the CG is shifted, it means the aircraft, when you're flying normally, will try to pitch its nose downwards. So to control this movement of the aircraft, which is automatic, which will happen according to the laws of motion, but to prevent this, they added one more. They've developed this MCAS, the maneuvering characteristic augmentation system, to control this unnecessary pitch down due to the change of CG, and this resulted in, although this directly didn't result in the crash, but the installation of the faulty sensors, which over the time, as you know, when an aircraft flies at an altitude above, say, 30,000 feet, so the sensors, they have heating system in it, so that the ice is not formed externally. Which, if in case of the speedometer as well, if the ice is formed, it will give the pilot faulty readings of the airspeed. So similarly, the MCAS was getting faulty reading, and due to which the pilot also didn't know the aircraft was forcefully pitched down by the autopilot system, which was thinking the aircraft is flying erratically. So they tried to save the aircraft. The autopilot reacted, and by the time the pilot realized that it was the APM that's doing it, it was too late, and eventually it crashed. So maneuvering characteristic augmentation system is a system which was designed to maintain the stability when and the center of gravity, which had been shifted a bit ahead of its actual point, so that the pitch down of the aircraft, which means you can also say the maintaining a higher angle of attack. To prevent it, they develop this system, and this system also, it's quite safe system, but because of the faulty sensor reading, few of the aircrafts were lost over the time. Now, a very important thing is the ILS. As you are all aware that the Deputy Chief Minister of Maharashtra, he died in a plane crash, I think a couple of weeks ago. Now, the very airport the aircraft was about to land, they didn't have ILS approach. Our Domdom airport or all big airports have an ILS approach. So it acts as a glide path, an imaginary line that guides the pilot to land and align the aircraft with the center line of the runway. So as you know, every runway has a center line. So for our Damdam airport, the imaginary line, the waypoint, there are basically multiple waypoints. So the waypoints, if you're landing from east, then the waypoint starts from Sundarban, and eventually it starts descending, and slowly it lands in the airport, aligning with the center line of the runway. But in certain runways, you don't have ILS. That time, you need to have proper visual of the runway, and if you don't have, it's very risky to land in such kind of a runway. And this is what happened with the aircraft that had crashed in Pune, which killed the chief minister, because of the weather conditions. The runway was not visible, and they were not aware of the center line of the runway, and eventually it crashed. But now I'll tell you that what does the ILS do. It basically, it there is a system in the the aircraft which uh, and the runway itself. You have seen many localizers, the antenna localizers, the antenna arena just at both the ends of the runway. So this is the ILS system of the airport, and this sends signals to the approaching aircraft so that it can align with the center line of the runway. And there are many imaginary waypoints. So this is a very useful, a very useful equipment for landing a large jetliner, and many pilots do trust it blindly, and in case of dense fog also they can land the aircraft. So this is a very useful technology that is there for almost now many decades, and it is evolving over the years. So, as I was discussing about the autopilot system of an aircraft and an UAV, so today now you can see the clear picture that why I was discussing. So this is a very basic on the right. You can see this is a very basic flight controller, the PICSOC, which is a very commonly used, very effective. So, and this in the left hand side you have the diagram of the autopilot system of a real aircraft, of a Boeing or an Airbus. So, end of the day, it's initially the very same technology which has been scaled down to work for the drones. It's nothing different, but it does the same work in a different manner. So, you have the APM module, you have the output. You can see the servo elements where the command, the servos in case of aircraft means the similar servos, the electronic servos which you mount on the aero model or the drones as well, or the BLDC motors can be instead of the servos. So it's initially the same thing, the GPS and your the gyros. So it's just a scaled down version of the actual autopilot system of an aircraft. So this is where the evolution and the conceptualization of the scaled down models, which are today we call it unmanned aerial vehicles, have started, and it has proven to be very effective, and it has revolutionized the UAV industry, uh, you know uh, from fighting wars to agriculture to photography to disaster management. We have a huge aspect of working in this kind of using unmanned aerial vehicles for such uses. So let's begin the discussion about the heavy lift UAV drones. So there are basically two categories of heavy lift drones. One is the multi-rotor category, as I'd shown you a video at the before few slides, the coaxial configuration, and this is a heavy lift multi-rotor. Then you have the heavy lift fixed wing, which is for combat. This is basically this version of the fixed wing was is being used by the US for nearly 2 decades now. So they are the two types of the heavy lift UAVs, which are capable of lifting weights, sometimes payloads above 100 to 200 kg as well. So these are some of the applications of a heavy lift drone. One is the agriculture, delivery, defense, disaster management, defense, and firefighting. So I have a wonderful presentation for the firefighting, which is waiting a few slides ahead. So I'll show you the presentation that how firefighting drones are going to revolutionize the future of firefighting in high-rise buildings as well as fires in the forest, which is you recently came across the fire in the California. So in fact, the forest fires recently in Manipur, I guess. So such fires need to be dealt very carefully. So I'll just straight away get to those slides. So this is the high-rise building fire in Kolkata, which happened on the left-hand side. You can see the G1 Bima building in 2017. This building, the top floor of this building engulfed in flame, and eventually the fire department, the headquarters, which is almost less than a kilometer away from this building, could reach the the source of the fire after 40 minutes. So that sounds quite that shocking, that how it took 40 minutes to reach, although being just a kilometer away, the headquarters being a kilometer away. So there are multiple reasons for that. When it comes to height, the fire department relies on ladders, and ladders are very heavy and large equipment. They need it's based on a big truck. It's a trailer based truck, and it takes time to travel to city traffic. You need to maneuver it. Then it requires space to assemble. In that case, this area was very much congested. There were parked vehicles, so they had to move the parked vehicles, make space, cut down trees because one branch was obstructing, and eventually they could give the first response after 40 minutes. So this gap, because the building was empty, it was on holiday, so there was no loss of life reported. And being the top floor, the loss of property was also less because it was on the one of the top floors of the building that the fire had engulfed. Now, uh, you know imagine if it would have been a much higher building instead of being a 13th story. As you can see just behind it, it's the 42, the tallest building, which measures 258 meters in altitude. So people staying above would not stand a chance. So for this kind of situations and this kind of fires, the ladder is a very slow method to give them the first response. So initially when fires happen, the first target is to save the lives of the people. Now, using the ladder is never the quickest way to give the first response. Ladder may be needed, or over the time for for rescue operations, or late in the later stage. But initially, the first response is very important to contain the fire so that it doesn't spread. Similarly, there's another picture of the 42 budding in 2018, which the external construction rope was engulfed, and which took almost 4 to 5 hours to control it. So these are the challenges which are being faced by not just fire departments in Kolkata, not in India, but it's a global challenge that recently there was a fire in Mumbai just a couple of days ago. In fact, there was a fire in globally in many high-rise buildings. Buildings are engulfed in flames and people are dying. But we need to have a quick and urban solution for this kind of fires. So I'll straight away uh, uh, show you a presentation on the firefighting drones that are being developed. So this is the ladder I was mentioning. That the ladder, it's a large and heavy equipment, and it takes time to travel to city traffic. So so it's a very slow method, but it is also needed. But we need a quicker method of firefighting for saving more lives, because urban life today lives and works on high-rise buildings. So we need more modern solutions to tackle this kind of fires.
Not interpreted by the audience.
Okay. So now this is the firefighting drone, which is, which will over the time help us, to tackle this kind of, deadly urban high-rise fires. So this particular drone is designed, it's a heavy lift drone, which is, which I showed you the video in the very first slide. We are the heavy lift drone. So this is a different kind, a more powerful version of the firefighting, for the firefighting operation. So this particular drone is designed to lift the hose, the firefighting hose from a fire tender. So it doesn't carry water. The water stays in the ground. The fire tender is in the ground, and the fire tender, the fire truck, basically, it is used as a source of water and pump. It pumps the water through the pipes, and what the drone does is similarly what was done by a firefighter, a human firefighter. He used to carry the hose up and then spray the water. But now the same work is done by the drone. The drone is doing the same work. Now, when you are lifting a hose of this kind, you are going to deal with a certain pressure. You're dealing with back thrust. When you're spraying pressure up to 6 to sometimes 8 bars of water. So, maintaining this kind of thing at pressure, and the discharge of water, sometimes 400 to 800 lpm, and lpm stands for liter per minute. It's 800 liters per minute. Then having the wind, as I mentioned earlier, that when you're flying close to a building, the updraft and the downdraft and the wind, the vortex, especially the vortex, which is every time next to a building, it becomes a huge challenge. So, but the firefighting drones over the time has evolved, and today it's successfully, it is ready for our operations. Although it will going to begin operations, in the later stage, or over the years. But this is one of the finest example that how this evolving technology, the drone for firefighting, can be used for saving human lives. As you have seen, drones, how it was winning wars for us, uh, in a very important aspect. But today, you have seen that how drones are helping us in fighting this kind of fire, and not just urban fire, but forest fires are also a part of it. And in fact, if you see in a city like Kolkata, Mumbai, Delhi, you have many localities which have narrow roads where a fire tender, it's not possible for a fire tender to enter. So in such places also, the firefighting drones with the extinguisher or the fireball dropping mechanism, these heavy lift drones, who may work in a cycle to to control the fire. You have seen when such fires happen in such localities containing the fire, or controlling the fire quickly, it becomes a huge challenge, and eventually a lot of loss of life and property happens. So firefighting drone are the examples of the urban solution, the people are going to get, so that when we are staying in a high, or working in a high rise building, so we know that there is something as an immediate response, so that it can protect any fire at any altitude, be it 258 meters, the tallest building here in Kolkata, or anywhere across the world. at least we are safe from fire and we have a quick response for it. So I'll just straight away go to the next slide. So these are some of the uses of the firefighting drone, as I mentioned, that in high-rise building fire, forest fire, and extinguishes fire in localities having narrow roads. So these are some of the benefits of having a firefighting drone. So these are some of the features. So this is the most important part, is the kamikaze drone, which is, you have seen during, this is one of the very basic concept design, because we can't share the confidential aspects of the drones that are being used by the defense. So a kamikaze drone is a drone, it's an attacking drone which is used for combat uses by the defense. And sometimes it depends on, it's just one of a kind. It may be a fixed wing, maybe a multi-rotor which is mounted with a weapon, and all it is designed is to deliver the weapon to a designated place, may drop it, or you need to, suppose a fighter jet, launching a missile. So similarly, a fixed wing aircraft launching a missile through it. So these are the, and it's all unmanned. So you must be aware, like you know that group captain Avinandan was captured, when his aircraft crashed in Pakistan, and he was eventually caught by the Pakistani, I think, the army, and later on he was brought back to our country safe. But to prevent such situations, instead of having a real aircraft with a human flying, this is where you stand the benefit, of having an unmanned aerial vehicle doing the job for you, instead of anyone physically going, and any harm happening, it will be happening to the device itself, to the aircraft itself, but there will be no human harm to it. So this is where the Operation Sindoor proved it, that with less loss of life, how wars can be fought with drones, and saving the lives of soldiers. It's a big example that the Operation Sindoor has proved, that wars can be won without having humans in today's world. So that's the biggest thing, and this is one such concept, that's a kamikaze drone, which is an attacking drone, and one of its type, a design. Now I'll come to some basic TGCA, regulations, which are kind of, very important when you want to fly a drone legally in India. But before that, I'll mention, because we have many engineering students here, I think. So, if you're developing any project for research and development in UAV systems, then you don't need any such certification, because DGCA has guidelines that you are allowed to make a drone for R&D purpose only. You cannot take it for commercial, but for R&D you can fly it and you can test it also. So that regulation is, or you don't even need a pilot license for doing an R&D, flying an R&D drone. But that should be within a green airspace. It shouldn't be somewhere near an airport or where there are restrictions. But it should be, you must always be aware that it's not a red zone. Red zone in the sense, DGCA, you have to go to the DGCA portal, and there is a part called Digital Sky of DGCA, which maintains the drones. So in that map, you have to see that exact location, maybe from an institute where you're flying, it's in the green zone or not. If you see it's in red zone, then you are not supposed to fly there. You have to search the alternate green zone in that map so that you can safely fly the drone. Now let's begin the drone classification, as I mentioned. But there is a nano category, which is from 250 grams. Then you have micro, 250 to 2 kg, nano, micro and nano category. These are widely in the categories where DGCA certifications are not mandatory. You can, these are mainly for basic uses. So mainly for aero modeling categories, they don't need they don't need license for hobby flying and all. But from the small category, which is 2 to 25 kg, and medium, 25 to 150 kg, it is a very popular category. And getting a certification in this category is creating a lot of job opportunities for in the defense industry. As you know, we have almost more than 100 and more than 100 successful to be successful UAV startups across India, working in various fields, from developing synthetic aperture radars, from developing agricultural drones, from developing various category drones, disaster management, surveillance, and providing various services using drones. DAAS, drone as a service. So in this category, the amount of drone pilots being needed is huge. India needs approximately close to 5 lakh drone pilots, by 2026 itself. It was a study done in 2023. So by 2000, in this year itself, we need 5 lakh drone pilots, and we are lacking it because we don't have proper drone schools all across India. We have only 100 drone schools, with West Bengal going to have its first one in IIT Kharagpur. Now, the large category is above 150 kg. In that category, mostly the defense drones come in. So, defense don't need civilian or the DGCS approval to fly its drone. So, in that category, DGC certification is not mandatory. That comes into the defense category drones. But the small and small category, you have the camera drones, you have the, many various surveillance drones, for mapping drones. And in the medium category, you have the most commonly used the agriculture drones for spraying, the agricultural fertilizers and pesticides. So, this category has abundant licensing opportunities in India, and getting one licensing and certification, a DGC certification, can help you be a part of this ecosystem, the drone ecosystem, by getting an employment. Now, there are certain rules you have to maintain, that you cannot fly above 400 feet, and if you want to fly above 400 feet, you need to get a permission for it from ATC, that so that you should know that ATC should know that you are flying in that airspace, and there will be no aircraft coming or approaching that airspace. So that is why there's a certain rule that you cannot fly above 400 feet without permission. Then there are certain things that uh, uh, you know if you don't follow the protocols, your license may be revoked. You might be given heavy fines, and the legal actions can be initiated against you. So there are certain rules and regulations, as you can see in the slide in the point 7, that where drones cannot fly, it's the red zones, especially the military areas, the international borders, state secretariats, strategic installations, overcrowds. So it's not mandatory that it has to be an airport where you will be flying the you're not allowed to fly the drone, but it may be the state secretariat or the military areas where it is an absolute red zone. You cannot fly an aircraft without any permission. So if you need to be in fact, for R&D purpose, as I mentioned, that you don't need any certification to fly it. You don't need to have an UIN, but you need to ensure that when you're doing such tests, that area, you need to inform the authorities that you're going to fly this drone. Then it is going to be create no trouble for anyone, because the Indian drone space is no more free, which it used to be for R&D earlier, maybe 10-15 years back. But now a lot of restrictions has come in. Although for R&D you can freely do it if it's in the green zone, there is nobody to stop you for that. So these are certain rules and regulations that you need to understand, and to fly and do a project on drone, and it's very important to know this. The RPC stands for remote pilot certification. Okay, so there is for um, the micro, the small, the medium, and the large categories. So it's like it's a say for the small category, DGC has a timeline. As I told you, drones are very easy to fly today. So DGC has given a duration of 5 to 7 days to complete each of the courses. So anyone who wants to get a certification, he can get it done in 5 to 7 days, and he can be certified to fly in, across anywhere across India legally. So this is the IIT Kharagpur Aerotus Drone Academy, which is coming up in March, April 2026. So as I mentioned, West Bengal is going to have its first drone academy. So this is where it's going to be starting, and IIT Kharagpur has taken this initiative. That's a big thing, and the first of its kind in West Bengal. So I'll straight away come to the UAV job opportunities for engineers and pilots in India. Especially for, it's not just that you need to have a drone pilot license, then only you can be a part of this industry. There are certain other requirements for the development, for the R&D, for the software part. As I mentioned before, that our mission is to focus on Atmanirbhar Bharat, so that we can become Vikshit Bharat by 2047. So to make this initiative, we need to we still don't have a proper indigenously developed APM module. So that's where the real the real problem starts, that we still depend on the APMs, the autopilot modules that are developed by other countries, and we have to get it from them. So getting an indigenously developed APM module is very much important, and to become indigenous, 100% indigenous, 100% Atmanirbhar product, made in India or make in India product. So we need the software engineers who can get it done, developing the proper the autopilot modules. And we also need UAV system integration engineers for the hardware and the software system to get it done successfully. So it's a huge R&D that many companies are doing it. And but the results are not yet successful, as the products that we are getting from other countries are way ahead still. So I hope that the kind of R&D we are having in India, we can definitely achieve it. But it's that it has multiple opportunities for engineering students to be a part of this aerospace industry. you know it's not just RPC, but engineering graduates can easily be part of this drone industry. Then you can be an UAV testing engineer, and for the quality assessment and all. So it's a huge opportunity for it's a booming economy, and it's a booming job opportunities for all engineering students in the UAV space across India. So now drone instructor is one of the most important part, because drone instructor is somebody who is going to the number two in the drone pilot and operation role. So it's he's somebody who is responsible training the future pilots. So this requires proper qualifications. So somebody who is highly qualified as a engineer, he can only that's the highest qualification. But he needs to be highly qualified to become a drone instructor, and that's certified by DGCA. So it's a long process, but somebody who gets a drone instructor license can be eligible to train the future drone pilots to an RPTO, in the future. So that's a big opportunity. And over the years now, it's 5 lakhs till 2030. But it 2026, but by 2030 it's going to be double, or maybe triple the numbers, the total requirement of the drone pilot. So it's a huge market, and it's the right time to be part of this industry, as the market is open right now. Then we have the survey mapping pilot, as I mentioned. Okay, so agro drone pilot. Okay, for this, the government already has schemes for the farmers, especially for the women self-help group, the farmers who they spray the insecticides and pesticides. And I mentioned this earlier, that Namo Drone Didi scheme, from where they get subsidies to buy a drone, and they also get training, pre-cost training by IFCO, to get themselves trained to fly these drones legally in India. So it's creating an entrepreneurship opportunity by having a own livelihood. So once this drones are bought, so local this the farmers are being trained to work as drone technicians as well, so that they can because over the next 5 years, we are going to have hundreds, or maybe more than that, drones in one village, or maybe not 100, maybe thousands. To maintain these drones, you need cheap skilled labor, cheap skilled technicians, sorry. So who can get these drones ready, repair for any malfunction, maybe very very minor malfunctions, like a broken propeller, which is very common, or certain components which require replacement over the time. So these technicians are also being trained by DGC approved RPTOs, so that they can also earn a livelihood. So entirely, if you see the UAV ecosystem, it's not just creating, high level jobs for the engineers, but it's also creating jobs for the, for the, for the technicians who are working at a very, initial stage. So, it's everybody who is going to get benefited from the UAV. So it's one such revolution that happened from the, from the aircraft, then aero modeling, and then today drone technology, which has given us the, idea that the aero modeling aspect can today, the designs you see, it's nothing, it's all aero modeling designs that are being used today, that are being implemented today. So it's all a revolution that, began in the early, say, 1940s or 50s, from structural designing to getting a successful design, which can sustain the pressure at, you know of 40,000 feet, and we can successfully travel in it. Then development of the autopilot system, then the TCAS, then the MCAS, and which has helped us to understand that we can develop the scaled down version of the autopilot system and mount this on the unmanned aerial system or the unmanned aerial vehicle, which we call drones, and use this for civilian and military purposes, has really proven to be very useful over the decade, and it's going to be much more better and make our lives much easier in the next few years. And it's going to revolutionize. The next slide I'm going to come with the drone mobility, for the air ambulances and the air taxis, which India is also planning to make Atmanirbhar Bharat initiatives, by making such things in India, which the defense is already working on it. So the unmanned aerial vehicle sector has UAV sector, the drone sector has really grown from in the last decade. So it's creating a lot of opportunities from people of every aspect, from engineer to technicians to to designers to pilots. So it's a booming drone economy in India, and it's going to it is predicted that the drone industry is going to have an increment of 0.3% in the GDP as well. So point 0.3 increase in the GDP for the drone sector is a huge amount for our country. So think that I'll come to the next slide as well. Now this is the drone mobility. As I said that having drones in the air ambulances, especially India has many places which do not have proper ambulance services, especially in villages. They don't have some remote villages who lack the access of proper roads for which the ambulance cannot reach. So for such localities, or for for disaster management, what happens in Assam very frequently, that floods which disconnect the roads, the giving, even in fact giving the emergency supplies become very difficult. So air ambulances are very essential. Air ambulances using drones, I mean drone based air ambulances, unmanned aerial system. This comes in the category of UAS, unmanned aerial system. So this thing is very important, and once this begin this services, it's going to be highly beneficial for all of us, all of us Indians, and it's going to be made in India and Atmanirbhar Bharat project. Then the development of air taxis for urban travel. Air drone mobility is something that's going to which US had predicted in the early 60s, that they didn't focus on railways in those days. They focused on creating more runways. Or is the presentation not visible? I got a
Actually, drone
message.
mobility slide. Yeah, drone mobility slide.
It's not visible.
It is visible,
Okay.
but the slide is drone mobility.
Yeah, drone mobility. I'm discussing this only. Drone
Yes, yes,
mobility.
yes. It is
Okay.
visible.
Okay. So somebody typed it's not visible, I think. Okay. So I hope it's visible to you. So okay, I'll just continue. So development of air taxis for urban travel. I'll just I was in the US part. So US focused on making more runways rather than making railways. So US has huge amount of airports all across its United States. You have many runways and many airports and many private aircrafts. They also focused on making highways to promote the heavily powered engine cars, but they didn't focus on the railways. So today, in India we are focusing on drones, and we are also focusing on such localities to create urban mobility, such that in the future that it becomes so efficient that we don't even need roads for such places to access. It's going to be so reliable, it's going to be so efficient, and it's going to be so safe above all, that in certain places, inaccessible localities, maybe in a hill, maybe in a deep forest where you don't have roads, but this service is going to be so popular, maybe in the next 1 decade, or it's going to be so reliable and so safe over the helicopters, that and cheaper to use. That's the biggest key point in this, and it's pollution free, it's a green technology. So this will be as drones and unmanned aerial vehicles has proven to be a very successful successfully implementing the projects, like be it in agriculture, be it in all sectors. So similarly, drone mobility using air taxis and air ambulances is going to be very successful over the time, so in the coming decade. Okay, I may discuss a few points after this, but if there is any questions from anyone, any students or faculty members, so I am ready to. You can ask me now. Anyone has a question?
Sir, this is very nice presentation and very
Your voice
useful.
is
Hello. Hello, can you
Voice
hear
is
me?
distorted. Yeah.
it's breaking.
Can you hear me, sir?
No, it's not audible, sir. Actually,
Hello.
yeah,
Can you hear me?
yeah. Now I can hear you.
Okay, so I have your presentation is very useful and a nice presentation. I have just one query
Hmm.
that the IMU and IMU you told one the instrument which is stabilize the platform and all the things,
Hmm.
and the gyro
IMU.
uh, IMU, yeah,
No,
inertial measuring unit, this,
okay.
and gyro.
Your voice is,
Uh,
it's not clear.
okay, I just
Please
type
type
it.
it. Ha ha. Please.
Yeah, yeah. Okay.
Any questions from the students, sir?
Yeah, I think that Mohit
Yeah,
Bishwas is
you can
his
ask me the
hand. Yeah,
question, Mohit.
Mohit, yeah, you can ask the question. Yes.
Air taxi and air ambulance technology of drone, this will be
Hmm.
emerging section, you said.
Hmm.
So any pilot needed or remote control technology?
No, no,
Physical
no. In
pilot
case of
needed to fly?
yes, yes. In case of air taxis and air ambulances, similarly, your modern aircraft, they are all autopilot, but you need a pilot to monitor the system. So when you are dealing with humans, there are certain rules and regulations of the FAA and the DGCA as well. So in fact, even if the aircraft is capable of flying autonomous, you need to have somebody to monitor the system. In case there is a malfunction, at least he can take the manual control and land it safely. Because autopilots, as I mentioned about the MCAS failure of the sensors, they all rely on the sensor. Similarly, we know you have seen the Tesla cars which are autonomous and failing to identify certain things on the road and crashing, on other vehicles, and causing a lot of harm. So you cannot, when it's a question of human travel, especially ambulance, when it's cost, it's about a human life. So, according to the rules, FAA and DGCA, any US system, be it air taxi or an air ambulance, it's not going to be fully autonomous. There will be someone a pilot to monitor the systems, and obviously as a pilot to fly it.
Thank you.
Students, any other question?
Yeah, Deepokash Paharia type the question. Can you explain the function of IMU?
It's not visible here. Wait.
His question is, can
Yeah,
you
yeah,
explain
yeah.
the function of IMU?
Inertial measurement unit. So you see, it's basically I was discussing about the TCAS, and I was discussing about the MCAS system. And IMU, it's a device that measures when the center of gravity of the aircraft is shifting. So it's something that the payload shifting of an aircraft. So basically, it's designed to measure many such aspects. But the payload aspect of the aircraft, you must have seen many aircraft like the Boeing 747. It's the cargo versions. So when the cargo, if the cargo suddenly shifts internally, although they are tied properly, so they are lifting heavy lifts, right? So if by any chance the cargo shifts during flight, or especially during takeoff or landing, so it is responsible for doing a quick inspection of the device, the maintaining the center of gravity, although it has many other functions. So it's designed to do this at a very quick quick interval, so that the pitch of the aircraft is not at all affected, although it has many other functions to do at the same time. Am I okay? Any other questions from the students?
Yes, Ninadi Chakraborty.
Yes, sir. In YouTube videos, we see that when they use the battery, which is 11.7 volt, like lithium-ion battery, so there the time we get the backup is something like 30 minutes and so on. If we increase the battery backup, and it may be a bigger size, and this weight may be increase, so the efficiency may decrease. So how to deal with this?
So first of all, you need to understand the payload capacity. When you are increasing the battery power, the payload will increase, right? The weight of the battery will matter. So that will also affect your flying time. Then what you have to do, you have to reduce your payload. You got my point?
Yes, sir.
Payload, you need to calculate your payload. If you're increasing the battery size, then you have to work on the power, the thrust that is generated, and the battery that consumption by your BLDC motors and ESC, the electronic speed controllers. Okay, so it basically drives the current from the PMU. Okay, the power distribution module. So you have to calculate the amount of current it's consuming, for the per minute or something, and how much battery. See, when you're flying a drone, you have a mission, you have to fly it for at least say 20 to 30 minutes. So you need to do a calculation that the battery must last for 40 minutes. So 10 minutes is the window. It's for any sort of mishap, or any sort of safety precautions you need for such kind of scenario. So you need to do the calculations accordingly and then make the drone. Battery increment is not a problem, but you need to do the calculations that how much consumption is there, based on your payload. And battery is also consumed, if the weather is not good, suppose it's a highly windy day, so the propellers and the BLDC, the flight controller basically fights with the wind to keep it stable for a stabilized flight. So that time, huge amount of battery is consumed. So it's all about, as I mentioned earlier also, that calculations, that the kind of design you are working on, and the payload capacity. That's how you will design a drone.
Can I change its design to improve this position?
Yeah, you can. You have designed a drone, right?
Sir, I see much more videos
You have
like
seen on
that.
YouTube. Okay, you have seen on YouTube, right?
Yes.
So you need to understand the design first. Okay, so what it is meant for. But then you have to understand if that if you increase the battery, obviously the flying time will increase. But if it has a payload, the battery's weight also matters. So that battery itself will act as a payload. You got my point?
Yes, sir.
Okay, so Devjit, they asked the question, what are the advantages of the drone swarm?
See, in drone swarm, multiple drones are flying together. In case of, you have seen in case of the Operation Sindoor, that multiple drones flying together. You don't have, multiple pilots, but one pilot or two pilots controlling the swarm drones. It's made. You guys engineers, you know it. It's based out of, done using algorithms. So you don't need multiple pilots to fly. You can fly 50 to 100 drones. And I think you must have seen also a few days back in Calcutta, we had a light show using drones, where more than, I think, 100 or 300 drones flew together to conduct this light show in the sky, the night. So this is a benefit. And in case of defense, having a swarm condition with combat or kamikaze drones is very much helpful, and very much it has proven to be very much successful. The Indian Army is procuring hundreds of swarm drones for surveillance and for combat uses. So it is a very useful useful swarm drones are very much useful for defense purpose especially. And yes, swarm drones can be used in metros also for logistics purposes, or for surveillance, for which will proven to be very much useful. So yeah, it will be very successful. Any other questions?
I think that there is no question, so you
Okay.
can continue. Yeah.
Okay, so I think I've already finished my last slide. So I'm just open for question answers now. So is there any question? Then we shall continue.
Okay, yeah. Then yes. If
If
there is no
students can
question,
come, or they can take my email ID if they have any questions later on. Okay, so
yeah,
you can ask me over my email ID as well. Okay, that any questions
yes.
you need any help, then definitely I'll be there to answer you. Just write it down. I'll just write it here.
Okay. So it is the
Any
time
student,
to,
you don't worry. You
yeah.
just drop me an email if you're working on any project. I'll guide you. Okay. So I just want to know that from which departments we have the students here mainly.
Actually, it is open to all. So
Okay.
I am not sure. Yeah. So
Like
our
I
affiliated
think
colleges
WBT
have
doesn't have
diversity.
aerospace. Aerospace we don't have
No.
here.
No. We
So
have no
we have
aerospace engineering.
CSC, I think CSC and electronics.
Yes.
You can see here many students are there.
Yeah, but not actually apart from the WBT affiliated, that means the MAKAUT affiliated colleges, other universities all over the India actually also participate in this workshop. Okay. So it is the time to conclude the session now. So actually I was listening attentively for so long. Really such a beautiful explanation. Interesting topic, of course. I'm sure that you also, all of you also enjoyed it. Thank you again to Mr. Ali for explaining this interesting topic so beautifully. So, and this lecture will be uploaded in our YouTube channel. So in future, if you want to just see the video, you can access our YouTube channel. Okay. So our session tomorrow will be on robotics and animation at 5 p.m. Hopefully tomorrow's discussion will also be very beautiful. So today we conclude the session. Again, thanks to Bebeto Ally for giving nice lecture.
Thank
So
you.
yeah, so conclude the session. Thank you. That's